Okay, so yesterday, we were just about at the end of section 12.1. And so, I guess we finished this one problem. And I guess I will do some additional problems in section 12.1, but I'm going to use the technique in section 12.2. So, I guess, so I'll do some more of these homogeneous equations. I'll do more homogeneous systems. Uh, oh, yeah, so right now, we're just finishing, this was the very, very last problem that I was doing in section 12.1. Okay, so I'll do more of these homogeneous systems from section 12.1, but I will use techniques from section 12.2. Okay, so let's do section 12.2 so that I can show you these techniques, because they'll actually simplify some of these sort of methods. And so, section 12.2, the Gauss-Jordan method. Solving systems for linear equations. So, let me first give you some terminology. And so, the idea of a matrix. So, a matrix is some sort of array of numbers. And so, a matrix is an array of, in this case, numbers. And so, if I look here, these are called rows. And so each of these up here are my rows, like first row, second row, third row. And these are my columns of my matrix. Okay? And so I have rows and columns. And so, let's say I have m rows and n columns. And this notation, m sub m comma n, is the set of all matrices. So another term, an augmented matrix. If I adjoin two matrices together, two or more matrices together, then I'll call it an augmented matrix. So more than one matrix. Yeah. So let's go. It's called an augmented matrix. So an example could be, I don't know, 3, 5, 6, 7, 8, 9. So this could be an augmented matrix. So I have this one matrix and this other matrix. And so this would stand for two separate matrices written together. And so this stands for this one matrix, 3, 5, 6, 7, and this other matrix, 8, 9. And we've just sort of adjoined them together. Okay. So note, you can write a system of linear equations as a matrix. And so I can write the system as AX is B, where A is the coefficient matrix. X is the variable matrix. And B is this non-homogeneous matrix. And then we can somehow simplify this system. So we solve it. Possibly. By just finding the inverse of the matrix. Of the matrix. Or we could write, so somehow we can denote the system also. As the augmented matrix. And then somehow try to simplify and try to rewrite in simpler form. And the simpler form will be sometimes called row echelon form. And it will be, I will be telling you about what that form means. So let me do some examples on page 522. Let me do, oops, let's say, number 4. Oops, someone has a question. So let's go back. Yes. Okay, to that part. And then tell me when to scroll down to it. Yes. Let's go down a little bit more. Thank you, got it. Okay. So let me do, let's say, problem number 1. In exercises 1 through 10, write the augmented matrix representing the system. And so I have here 5x minus 7y equals -1, 2x plus y equals 2. So first, let me actually write it in the matrix form. And so let me write down the coefficients. 5, 2, -7, 1. Let me write down the variables, x, y. And let me write down the non-homogeneous part, -1, 2. So this is called the matrix form. Okay. So again, this was my coefficient matrix. This was my variable matrix. And this was my non-homogeneous matrix. So now let's write this as an augmented matrix. To write as an augmented matrix, we would just write down the coefficients, 5, 2, -7, 1. And then next to it, adjoining to it, would be the non-homogeneous part. This is the augmented matrix. And that's what I wanted. do problem number, let's see, 6. Negative 2x. Oops. Problem number 6. Negative 2x minus y minus 3z equals negative 3. Negative 2x minus y plus z equals 5. 4x plus 2z minus 2y equals 2. Okay. Now, the only thing you notice here is that in this case, I have x, z, then y. But in all the other cases, x, y, z. So I have to rewrite this. So let me rewrite the whole system. So negative 2x minus y minus 3z equals negative 3. Negative 2x minus y plus z equals 5. And 4x. Again, write the y first, so minus 2y. In the z plus 2z equals 2. And so now, let's write this as a augmented matrix. And so, negative 2, negative 2. Oh, I can write this wrong. Negative 2, negative 2, 4. Negative 1, negative 1, negative 2. Negative 3, 1, 2. And negative 3, 5, 2. That is my augmented system. And that's the way I want to write my augmented matrix. Let me do problem number 4. X plus 2y plus 4 equals 0. Y plus 2x minus 1 equals 0. Let's rewrite these. And so let me subtract 4 from both sides of my equation so that the non-homogeneous part, the part that does not include the variables, is on the left side. Let me write the x first, then y. Add 1 to both sides of my equation so that the non-homogeneous part is on the right-hand side. Then I can write this as a augmented matrix. 1, 2, 2, 1, negative 4, 1. And that is my answer. Okay. All good and fine. Let me do problem number 14. Oh, that's small. Let me do problem number 12. 0, negative 3, 1, 4, 2, 3. In exercise 11 through 16, write the system of equations for the augmented matrix. And so, I want to rewrite this as a system of linear equations. And so, it doesn't tell me what the variables are. And so my variables can have any name. So notice that this is just sort of a lazy way of writing a system. I just rewrite them without saying anything about the names of the variables. So that saves me a little bit of time. But of course, when you want to go back, uh, then you have to give me some names for variables. So I call the first variable x, the next variable y. So 0x plus 1y equals 2. Negative 3x plus 4y equals 3. And that is my system of equations. Of course, I could have used other names for variables. I just happened to pick x, y. Let me do maybe one more of these. Let's say problem number 15. 3, negative 9, 6, 2, 1, negative 1, 1, negative 1, 2, 8, negative 20, 16. So let's write this as a system. I guess I'll call it x, y, and z. And so 3x plus 2y plus 1z equals 8. Negative 9x plus 1y minus 1z equals negative 20. 6x minus 1y plus 2z equals 16. And that is the system of linear equations corresponding to this augmented matrix, where I've picked x, y, and z as the names for my variable. Let me do problem number 18. 2x. Let's call this row 1. 2x plus 4y equals 2. Row 2. 3x minus 5y equals negative 8. Okay, in exercises 17 through 40, solve the system by using the Gaussian matrix. So let me solve this sort of the way that we've done it before, and then I'll show you that really this is the same method that we've been doing before. And so I guess let me, if I look at row 1, actually I can simplify it. So why don't I simplify the first equation first? And so let's do that. So let's just take R1 and divide it by 2. And so that gives me 2x plus 4y plus 4y equals f2. Let's divide each of those by 2. And so I get x plus 2y and 1. I guess I'll just call that S1. Okay. And maybe I'll call the second one S2. So I can have all S's. And so now I want to somehow get rid of one of the variables, and so maybe I'll eliminate x. So let me eliminate x. chose to eliminate the x variable. So let me multiply the first equation by -3. And add that to the second equation. So let's do that. And so the 3x's cancel. So I have no x minus 11y equals -11. Let me divide both sides of my equation by -11 to solve for y. And so divided by -11, I get that y is 1. Okay? And now I can determine what x is. So I can plug into, so now I'll solve for x. And I can do that by plugging into S1. And so I have 1x plus 2y equals 1. So I can subtract 2 from both sides. And I get x equals -1. And so that's my solution. Any questions about any of those steps? Okay. So now I will, that's why I sort of separate this out. So this was the old way. So now what I'll do is I'll just sort of do it the new way, which is using what's called this augmented matrix. And so let me rewrite this system as augmented matrix. And so if I do that, I get the 2, 3, 4, -5, 2, -8. And so now, so that's the first step, write this augmented matrix. The next step is to find what's called a pivot. And so if I look in the very first column, and I look at the highest, meaning the very first non-zero element, well, the very first non-zero element is 2. And so this is called my pivot. And so now let's perform the pivot step. Okay. And so what I'll do here is I will try to divide this first row by whatever number is my pivot. And so I'll take the first row, divide by 2. I'll give me a new first row. 2 divided by 2 is 1, 4 divided by 2 is 2, 2 divided by 2 is 1. Next, I want to make whatever is below the pivot equal to 0. And so I'll multiply this new first row by -3. And add to the second row to the new second row. What makes 2 the pivot? If you look in the very first row, it is the first non-zero number. And so it was the guy here. So if you add numbers, that's the pivot. Now, once you've chosen this and you've performed the pivot, then you go down one row. It's the first non-zero number in the second. And then once you've figured out whatever that is, it will be the first non-zero below the next one. Okay. So now, the pivot operation says you want to make whatever is below the pivot equal to 0. So negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 2 is negative 6, minus 5 is negative 11. Negative 3 times 1 is negative 3, minus 8 is negative 11. Which was this step here. And so, I've now put this into what's called, row echelon form. In row echelon form, whatever is below this diagonal is 0. And so if you take the diagonal and everything over here is 0, then we say it's in row echelon form. Now, let's perform back substitution. Back substitution says, write this step here, is that we take the last row, 0x minus 11y equals negative 11. Solve for that. So let's divide by negative 11. So I get y equals 1. Same step here. So these are all the same steps. And now, to back substitute, it says now plug that answer into the previous row. And so let's look at the previous row. 1x plus 2y equals 1. And so I have x plus 2 equals 1. Subtract 2 from both sides. So x equals negative 1. And so again, we get the same solution. And you notice same steps. So what is the only difference between what we did before and what I'm doing now? One is notation. Two is, before I sort of said you had any choice. You can eliminate any variable. You can use any sort of equation to eliminate variables. Unfortunately, that gave you too many choices. And so what that meant is that you could get lost in the desert. So now I'm I'm this I'm the sergeant, and you're the soldiers in the desert. And now I tell you, you can only do one thing. You can only start to eliminate x first, then y, then z, etc. So you go in order, and you can only eliminate x or whatever. First you use the first equation to eliminate x in the second equation. Use first equation to eliminate x in the third equation. Use first equation to eliminate x in the fourth, etc., etc. Go all the way down. Then after you eliminate all the x's, then you eliminate y using the second equation to eliminate y using the third equation, etc., etc.
And so it's very specified. You can only go in order. What you do, can you go over the steps? Yes. Sure. So the steps are, I'm going to do more than, I'm actually going to do several of these, is first you rewrite your equation as an augmented matrix. Next, you determine your pivot element. Then, and your pivot element is the first non-zero number. If the first number is 0, then you can interchange rows so that it will be non-zero. Perform the pivot operation. The pivot operation makes everything below the pivot 0. Once you have completed all pivots, then you do back substitution to solve for all the variables. So let me do another example. Oh, let's say what you will notice is that there isn't a lot of writing in this technique. So let me do, let's say, problem number 30. So this is a 3x3 system. If you remember, 3x3 systems always took us forever to do, but using this technique will be much shorter. So x minus y minus z equals 1, 2x minus y minus z equals 0, 3x minus y minus z equals 2. Okay, so first step, rewrite this as an augmented matrix. And so let's do that. 1, 2, 3, negative 1, negative 1, negative 1. Negative 1, negative 1, negative 1. 1, 0, 2. Okay? So I've rewritten my system as augmented matrix. Any questions about that? Now, let's pick the pivot element. And so, look at my first row. Start at the top. If this is non-zero, then that's a pivot element. If this were 0, then you would find the first non-zero number and interchange rows so that it would be in this location. If all of them are zeros, then you go to the next one and see until you find. Okay, but this is already non-zero, so I'm happy. So now let's perform the pivot operation. And so I want to make, and so the very first row, 1, negative 1, negative 1, 1. That's not going to change. Now let's perform the pivot. So I want to make this 0 by multiplying this row by some number to make that 0. Since this is a 1, just multiply this first row by negative 2. When you add to the second row, then this will make this term 0. So you'll take the second row, subtract 2 times the first row, give me a new second row. And so this says, take the second row, subtract from it 2 times the first row. That would give me a new second row that I'll write here. So let's do that. And so 2 plus a negative 2 times 1. 2 minus 2 is 0. Negative 2 times negative 1 is a positive 2. Minus 1 is 1. Negative negative 2 times negative 1 is a positive 2, minus 1 is 1. 0 minus 2 times 1 is a negative 2. Let's try to make this element 0 by multiplying this row by the appropriate constant, well, by negative 3. And so I'll take the third row, subtract 3 times the first row, to give me a new third row. And so 3 minus 3 times 1 is negative 3 times 1 is 3, minus 1 is 2. Negative 3 times 1 is 3, minus 1 is 2. Negative 3 times 1 is negative 3, plus 2 is negative 1. Okay. So now we're almost done. I can almost fit it there, but not quite. And so I've performed my pivot. My pivot operation has that everything, I found my pivot, 1, this circle, and then I made everything below my pivot 0. Therefore, I'm done with that operation. Now go to the next column. This was my pivot. So I need to go one row down and pick the highest, the first non-zero number. Well, there it is. Okay. I need to make everything below it 0. But I noticed that kind of nicely, I can make everything above it 0 also, so I can do that. So let me do that. I'll just make my life a little easier. And so, oops, I don't want to do that. So let me just specify. And so, this will only make my life easier, and so I'll do it. And so if I notice, I can take the first row, add to it the second row, and I'll get a simpler first row. So let me do that. So 0 plus 1 is 1, 1 minus 1 is 0, 1 minus 1 is 0, and that's why I like that. And negative 1 plus 1 is negative 2 plus 1 is a negative 1. Let me keep the pivot row. Now I want to make what's below it equal to 0. So let's take the third row, subtract from it 2 times the second row, give me a new third row. 0 minus 2 times 0, 0. 0 minus 0 is 0. Negative 2 times 1, negative 2 plus 2 is 0. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times negative 2 is positive 4. Minus 1 is 3. So now what I notice is the following. If I rewrote this, so now I'm done because I have it in row echelon form. If I look at my diagonal, everything below my diagonal is 0. But if I look at the very last row, I have 0x plus 0y plus 0z equals 3. So this says 0 equals 3. Can 0 equal 3? No. And so that means that this is an inconsistent system. That means that this equation has no solution. And so the system of equation is an inconsistent system. It's this last equation here is a contradiction. This system has no solution. So notice, in general, if you have a row then you know you're done. Then this would automatically give you an inconsistent system. No solution. Similarly, if you happen to have, well, if this turned out to be zero, if you have a whole bunch of zeros and this is zero, then it is probable that you'll have an infinite number of solutions. Okay, and we'll come to that. Let's do some more of these. So notice that this was much shorter than what we did previously. If you remember when we did 3x3 systems, took up the whole board. I had a hard time writing them all down. And it took the whole class period to do it. So this notation is somewhat nicer. Let me do, let's see. How about problem number 40? Let's do problem 40. X plus y plus z equals 3. 3x minus 2y plus 4z equals 4. 6x minus 2y minus 3z equals 10. Okay, so let's do that. And so let's write this as an augmented matrix. 1, 3, 6, 1, negative 2, negative 2, 1, 4, negative 3, 3, 4, 10. Okay, so let's choose this as my pivot. I'll keep the first row. And when we hit the second row, because this element below the pivot in the second row equals 0. Let's hit the second row. Subtract 3 times the first row. 3 minus the second row. 3 minus 3 is 0. Negative 2 minus 3 is negative 5. 4 minus 3 is 1. 4 minus 9 is negative 5. Let's try to make this element here below the pivot 0. So let's take negative 6 times the first row, add it to the third row. So take the third row, subtract 6 times the first row. So 6 minus 6 is 0. Negative 2 minus 6 is negative 8. Negative 3 minus 6 is negative 9. Negative 18 plus 10 is negative 8. Okay, and so let's pivot. Now what I'm going to perform is what's called fraction free. So I'm going to do this as a fraction free. So in classical Gauss-Jordan, so I guess I should sort of say what these two techniques are. So in Gauss-Jordan, so notes. So note for Gauss-Jordan, we want to make all of these zeros, and then your numbers will be. Okay, and so you want to make everything along here ones or possibly zeros. And so along the diagonal, only a zero or ones. Okay. And all other, there's the others, and the off diagonals are zero. And then obviously these are just some numbers. What are they? Okay. In Gaussian method, so Gauss. So in Gauss's method, the along the diagonal, you only have zeros or ones, and below the numbers below the diagonal all zero. Whereas for fraction free, below the diagonal, are zero. And you don't have any other condition. You could have non-zeros, any sort of numbers along the diagonal or above the diagonal, on the right-hand side. Okay, so let me continue this with my fraction free. And so if I suppose I had this, so we're going to explain equals -5, sorry, and -8y, 8, 9, -8. Okay, so suppose that we have, so negative 5, 1, negative 5, negative 8, negative 9, negative 8. Okay, good. So suppose I had these, call them R1 and R2. And suppose I want to eliminate y. Well, then what you do is you multiply the first equation by negative 8. Oops. I hope that didn't make anything. Okay, sure. And so, let's do it by positive 8. And then, so I'll get a negative 40y plus 8z equals negative 40. And let me multiply by negative 5x. The negative 5, 2, so it becomes positive 40y, positive 45z equals positive 50. Then I can add them. So if I do that, the y's cancel. I get 53z equals 0. Okay. I'll do the same exact thing for my fraction 3. So let me copy this, because I'll forget what it is. I'll just sort of put it somewhere. Let me copy this for a second. Copy. Oops. Let me paste it back. I accidentally got rid of it. Okay, and let me put this somewhere I can see it. So we have this from before. Okay, so now let's do the pivot. So I'll keep the first one. First row. 1, 1, 1, 3. I'll keep the second row. Oh, let me take, yeah, let me keep the second row. And now I'll take, what did I do? 8. So I'll take 8 times the first row, 5 times the second row. Except those are now called different things. That's the second row, and that's the third row. It may give you third row. Okay, so I'll take 8 times this first row, negative 5 times the second row, to give you negative 5 times, so 8 times the second row, negative 5 times this third row, to give you a new third row. And so 0 plus 0 is 0. Negative 40 plus 40 is 0. 8 plus 45 is 53. Negative 40 plus 40 is 0. And now I can best, so now you notice that it is upper triangular, that the lower triangle here is all zeros. And good, so that means that I can use back substitution. So let's solve this by back substitution. So now you can solve by back substitution. this technique here will save you from a lot of the fraction. Well, it'll save you from having fractions within the matrices. Of course, your answers may be fractions, because you can't get away from that. But at least within these steps here, you won't have fractions. So I have 53z is 0. Divided by 53. And so z is equal to 0. Good. So now let's determine y. So by the second row, I have 0x minus 5y plus 1z equals negative 5. And so I have negative 5y equals negative 5. Divide both sides of my equation by negative 5. And so I have y is equal to 1. And lastly, let's plug into the first row to determine x. So I have x plus y plus z is 3. And so x plus 1 is equal to 3. Subtract 1 from both sides. And so I get x is equal to 2. And we're done. And so, of course, it would have been shorter if I didn't have all those previous steps for explaining it in. But if you notice here, the actual solution is much shorter than what we've had in the past. Okay. So let me, there's a whole bunch of word problems here, but let me go back to section 12.1, because I wanted to solve some of those bigger ones that, without this notation, would be a little bit unyielding. So, here. There's a 4x4 system. So now we can tackle 4x4 systems much easier with this notation. No, it's not so bad. So let's go back to section. So page, pages is 513. This is section 12.1. Okay. So let's do this. Problem number 50. So I have x plus 6y plus 3 z plus 8w is 0. 2x plus 4y plus 6z minus w equals 0. 3x plus 10y plus 9z plus 7w equals 0. I can already see what's happening here. 4x plus, oh really, 16y plus 12z, how nice, plus 15w equals 0. Okay, so I can see this is going to have a two-parameter family solution. So let's do this. So let's write my augmented matrix. And so 1, 2, 3, 4. Try that again. 1, 2, 6, 4, 10, 16, 3, 6, 9, 12, 8, negative 1, 7, 15. Now, since the right-hand side of my equation is always 0, and so anytime I multiply any row by any number and add it to another row, I'm always going to get 0 on the right-hand side. And so we're lazy, and we just don't write in our augmented matrix all the zeros. So we just write it this way. So my augmented matrix is actually just written in this form. Again, because we're lazy. We don't need to write all the zeros. And so I'm not going to write them. So that's pivot. And so let me pivot on the 1. Yeah, that's nicer. So let me keep the first row. 1, 6, 3, 8. So let's make whatever's below it 0. So I'll take the second row, subtract 2 times the first row, give me a new second row. 2 minus 2 is 0. 4 minus 12, negative 8. 6 minus 6, 0. Negative 1 minus 16, negative 17. Let's try to make this 0, so I'll take the third row, subtract 3 times the first row, give me a new third row. 3 minus 3 is 0. 10 minus 18 is a negative 8. 9 minus 9 is 0. 7 minus 24 is negative 17. Let's try to make this last one 0. So let's take the fourth row, subtract from it 4 times the first row, give me a new fourth row. 4 minus 4 is 0. 16 minus 24, negative 8. 12 minus 12, 0. 15 minus 32, negative 17. Okay. So we're done basically, but I'll just go one more step. Make it look a little nicer. And so let's pivot. So I'll keep the first, second, rows. And so let's do the third row. That's the second row. The third row. 0 minus 0. 8 minus 8, 0 minus 0, 17 minus 17. And let's take the fourth row, subtract from it the second row. And the fourth row. 0 minus 0, 0. 8 minus 8, 0. 0 minus 0, 0. 17 minus 17, 0. Okay, good. And so, when you happen to have a consistent system, so if the system is consistent, and in echelon form, in row echelon form, all the zeros have got to be at the bottom. And so, row echelon form, say 1, 0, and a whole bunch of zeros here at the bottom. So if I have a whole bunch of rows of zeros at the bottom, then, and if the system's consistent, the number of rows of all zeros gives the number of parameters. Okay, so in this case, I notice that I have 2 rows of zeros. Therefore, that means, so therefore, 2 parameters. So this will be a 2-parameter family solution. And so let's do this. So I can, well, I don't know, let me give those parameters, I don't know, R, maybe S. That's enough. So, let's say W equal negative 8R. Okay. Then, some of these will look a little nicer. Then I have, let's see what that last, here it was. And so, none of these rows involving zeros will give me anything. I have 0x minus 8y plus 0z, oh there it is, minus 17w equals 0. Let me solve here for y. And so I can divide actually by negative 8. And so negative 8y minus and minus is a plus 8 times 17, 136r. And so let me subtract 136r on both sides of my equation. So negative 8y equals negative 136r divided by negative 8. Why is that? Oh, no wonder it looked different. I thought something was fading away. I used orange rather than red. So I got red. Divided by negative 8. And so y equals 17r. Good. So notice I've got w and y in terms of r. So now I want to plug that into the first equation. And I don't know, maybe I'll just let z, x, y, z, I'll let z be something. I'll let z equal s. Let z equal s. Then I have 1638. 1638. 1, 6, 3. Oops, what was that? 8. Okay, so 6 times 17 r plus 3xy z plus 8 x negative 17, no, negative 8. Let's solve this. And so I have x plus 102r plus 3s minus 64r is 0. And so I have x plus 38r plus 3s equals 0. Subtract 38r, 3s for both sides of my equation. So you get x equals negative 38r minus 3s. So my solution is negative 38r minus 3s y 17r z s w is the negative 8, right? Negative 8. This is a two-parameter family of solutions. This will be a plane in 3 dimensions. And so this is a two-dimensional plane in the XYZ. Okay. And so this is for all R and S. Any questions about that? So that gives you, so this is would have been fairly untractable if we did it, if we tried to do it just in our previous notation. Okay, let's see. Maybe we have enough time to do another one. That's 6 minutes. Let me just check. Actually, maybe not. Maybe I'll leave it at this for today, and then so I can do it on Monday. So I can do some of this live in front of you guys. Okay, so any questions about anything? You're still trying to answer problems. Yeah. Yes, I am. But I see everyone saying, no, don't do it, don't do it, don't do it. Oh my God. Yes, we can't. Oh my goodness, we can't see you. Oh, oh no, we can't. I didn't hear anything. Oh no. We haven't been able to see anything for 40 minutes. Okay, well, I guess, well, actually, but luckily it was taped on this guy. Was this taped? Yes.